Okay. So I have a structure. Basically, I don't know what the structure is, and it's going to undergo a Grignard reaction. This is Mg and ether, right? Mg and ether. And then I get another compound here. So I have some compound here, A, some compound B, and then afterwards I'm going to, that reacts with, this is CH3CHO, which is ethanol, CHO, and then secondly, it's an acid workup H3O+. Right, so I have two, and then I get this this product here. So 1, 2, 3. Let me just make sure I draw this correctly. OH here, bond here. Okay, so I have something like this. Okay, so how I would approach this problem is I would actually redraw ethanol into actually the line diagram here. So one, this is actually O, and then this here is H. So I would actually redraw it as this. Because once you realize that you drew it as a line diagram, it's actually very easy to see what the Grignard reagents are made up of. So I have, if you look at this here, again, Grignard reagents are carbon-carbon. It helps with making carbon-carbon bonds, right? So as here, I can see I have 1 and 2 carbons here, right? So this is the first carbon of ethanol and the second carbon of ethanol. This is exactly the same as the final product, right? This here is 1. And this here is 2, right? Which means my Grignard is going to have to be made up of 3 carbons, right? I have a total of 5 carbons here. So which means my Grignard has to be made up of, this is 1, 2, and 3. So it has to be a propyl group in terms of my, to make up my Grignard here. Which means, therefore, A here, A simply has to be, in order for me to get a Grignard, I need MgX, right? And X can be any halogen here. So I would have to simply just draw a propyl group, so 1, 2, and then X here. And X could be either Br or Cl. So then in this case, I'm just going to pick Br because I'm used to using bromine as my kind of my go-to halogen. This is a bromide group with a three carbon chain. It's going to Mg and ether. It's going to make this a Grignard. It's going to activate the Grignard, right? So this here is now Mg bond Br here. And basically what this does is it actually pulls, this is a positively charged magnesium, it's very, very positive here. And this makes this carbon-carbon like very, very negative. And what it does is going to then attack this negative charge is going to come and attack this partial positive that exists here. This is going to get kicked out, and then you're going to produce an intermediate that looks something like this. So let me draw out the intermediate for you. I'm going to do it in blue, maybe, or maybe in red. The intermediate looks something like this: 1, 2, 3, 4, 5, and then you have a double bond here, and then O. You have a double bond O here, and then you have also. No, it's not. It's simply just a single bond O. Sorry, single bond O. And then it's O minus here. And the acid workup, this H here, provides this positive here. This H3O plus here provides the hydrogen to make it a hydroxyl group here. So basically, that's kind of the mechanism for this Grignard reagent here. Again, let me draw my lone pairs for you. It makes it a bit easier, and it produces this alcohol here. So let me just check my answer to see if this answer is correct. So again, I have a propyl group, which is A123 Br good. Mg and ether provides a negatively charged carbon with a positively charged bromine. That's good. It's going to come and it's going to attack this double bond, which is partial positive here, and then it's going to come and break this oxygen group. And then they didn't draw the intermediate here, but you get the intermediate like so. And then this is going to then produce. I didn't draw the arrow. This produces my my alcohol here. So this here is a correct solution. They didn't show the intermediate, but it's fine. This here is a great solution and analysis. So again, this is simply just a Grignard reagent, carbon-carbon reaction here. So this, here.